So the idea today in this session is to not only just tell you how you can use MaxQuant for DIA data analysis, but also like a general feeling of how the software functions, right? So to be able to run MaxQuant, you would need to have .NET Core 2.1 installed on your computer. So I'm going to start from the very beginning, and I'm going to assume that you have never run MaxQuant before, right? So now I will share my screen with you. There we go. So what you need to do if you don't have .NET Core 2.1 is you need to browse to this website. And let's see if I can make this go away. No. Need to browse to this website from Microsoft. And what you need to do is, depending on whether your computer is a 64-bit system or a 32-bit system, I bet most of you now these days have a 64-bit system, download the SDK for Windows by just clicking this button over here, and your download will start, right? And then all you need to do is find where this file has been, this executable has been downloaded to, and you just click on it and continue with the installation wizard. It's pretty straightforward. You click install, next, 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 and you will have your .NET Core 2.1 installed. After having done this, if it wasn't installed, what you can do is you can go to our website, so maxquant.org, right? And the landing page, the home page here is MaxQuant. Obviously, we have Perseus, we have the plugins, we have MaxQuant Live, we have also our summer school page here and documentation. What we need to do is we need to click on the download button, and we come to this download form that we have here. Now here, all you need to do is enter your name, your email address, and your company or institution name. All the other information are optional, and you need to agree with MaxQuant's license terms. Then you click download, and what will happen is in a few minutes, you will receive such an email in which you will be provided with a download link. By clicking on this download link, your download will start, right? And you will end up with such a zip file with MaxQuant underline and the version that you have downloaded. Now, what you need to do is you need to, of course, find this file on your computer, and you need to extract its content since it's a zipped file. Now, all you need to do is you need to right-click on this file, you need to say extract all, and then you get this Windows dialog, and you can specify where you want this to be extracted. If you don't touch anything, it will be extracted to the same folder. I've already done that, so I'm not going to do that now. And then you will end up with such a folder with MaxQuant and its version number written down. Now, if you go inside this folder, again, there's another folder named the same way, and then you go inside that one, and here you can find the MaxQuant executable. Now, all you need to do is double click on this. So this is MaxQuant, like so. It has a nice graphical user interface, which makes our lives very easy. Now, what we need to do is we need to either press the load button to load our raw files, or let me just press it now. So I can navigate to my USB disk where my DIA data lies, right? I double click on that, and I can see my raw files are here. I can either select these two raw files and press open, or I could have even dragged and dropped my files there by just selecting them taking them, coming to MaxQuant and dropping them here. Both work, doesn't matter how you want to do that. Now, after we have loaded our files, we see that this table is updated with the location of our file. It tells us if the location is correct. So if for any reason you had if you move the files, for example, this will say false and it will give you an error. We see the size, we see the format. The files that I'm showing you are from the thermal instruments. We have the parameter group column. This allows us to have different parameters for different profiles. I suggest you have a look at some other MaxQuant tutorials on YouTube where these things are explained in much more detail. This tutorial will be specifically on how to run a DIA run, right? So these concepts are explained there on YouTube if you are interested in that. For this exercise, we don't need the parameter group column. Then we have the experiment column. This is where you set your condition and control properties. So let's say, hypothetically, this was my condition, and this is my experiment. So what I did was I selected the file or files even, and I pressed on set experiment, right? So that was my condition, and this is my control. You need to do this so later on your life is easier. You can also have several files as condition or several files as control, depending on how you have set up your experiment. You can set the fractions here if you have fractionated your run by using this button. In this case, we don't have it. PTM for now is irrelevant for MaxDIA, but the PTM version might be coming. Also, reference channels are for labeling. So in this case, we don't have them. Now, other things that we can set up here are the number of processors or threads that you would like your run to use, right? By default, this is set to 4, and you can increase or decrease it depending on your system. Another thing that is very useful in MaxQuant is that every time you hold your mouse on any of the parameters, a nice explanation will appear for you to read. Use this to make your life easier. Now, you might say, okay, I don't know how many processes I have, and how can I find this out? To do this, you press on your start button and you type system information. And just by saying sys, it comes up, right? You click on that, and here, by expanding this column here, you can see your processor information, right? So it's telling me that I have 8 cores and 16 logical processors, which I can use to run MaxQuant. So I have 16 available. Now, we would recommend you take at least 2 to 4 gigabytes of RAM per processor. So if you have 32 gigabytes of RAM, take something like 8 processors, right? And no more, or maybe you want to try 16, but we currently recommend to have 4 gigabytes of RAM per processor. Okay, this is the start button. We will press this at the end, but not now. And let's move on now to setting our group parameters. So we go to the group specific parameters. Now, this is exactly where you are going to select the type of experiment you have. And this is exactly, so for standard DDA, the type is by default set to standard, but we are going to do a DIA run. And for that, we can select either MaxDIA, we can select msDIA, or we can select boxcar MaxDIA. And this depends if you use a timsTOF device, if you use the boxcar acquisition, or if you use the standard DIA. So our files are standard DIA, we select that. And we can wait after that. choose the type of library that we are going to be using. So by default, this is set to MaxQuant, but you can also set it to TSV for third-party software that you have used to process your library, DDA library runs, or any other kind of software that can provide you with such a library to use with DIA runs. For now, we set it to MaxQuant. Now, what you need to do is you need to provide peptide files, evidence files, and msms files. And these are text files that I have here, and I get these text files either from, so in this case, I'm talking about when you have a measured library, I get it from my previous MaxQuant runs that I have done on my DDA data for libraries. And that usually, let me see if I can find that for a second. That usually lies in your combined folder. Just ignore this DIA here. Think of it as the DDA run. You go into your combined folder of your MaxQuant run. You go to the TXT folder, and you can find these files there. So peptide, evidence, and msms is what you need. So all you have to do is you have to say add files, and you select your peptide, you select your evidence, and you select your msms files. Just to make clear once more, these files are inside the combined folder within your project folder of the DDA run that you have done to use as a library. And later I will tell you what you have to do and where you can get these files if you want to run MaxDIA in its discovery mode using spectral library prediction. Okay, so that's that. We have now set our library files here. The next thing that I would like to show you is the instrument tab here. Now, this is where you select the instrument type that you have used. So your Orbitrap, Bruker devices, Sykes devices, Agilent devices, and so on. Our data comes from the Orbitrap mass spectrometer, and so we keep it as it is. Now, here you can find a lot of parameters, really very many parameters, and from the middle onwards, you can see that many of these parameters are specific for DIA runs. Now, MaxQuant tradition is that you don't touch anything. Everything that is default should stay like that unless you really specifically know what you're doing, right? So if you don't have a reason to change something, don't change it. And many of these parameters have been optimized by us, months of benchmarking and making sure that everything is set up to its very, very optimum value, right? If you want more details about each of these parameters, you can hopefully in the very near future have a look at our publication and see if you need to touch any of them. Okay, next we go to our label-free quantification tab. Now, as explained by Jürgen and Pavel, this is the MaxQuant quantification algorithm that we also can apply to DIA runs, and this makes everything very, very much more comparable than before when you were comparing DDA runs analyzed by MaxQuant and DIA runs analyzed with other software. So all you need to do is to turn this option on, is click here and select Q, right? And then you also get some parameters that you can change, and these parameters and how MaxQuant is functioning has been covered by previous talks, and of course there are also many talks. Again, I would like to remind you on YouTube that you can check which go into the details of such algorithms within the software. Okay, so now what we need to do is we need to go to the global parameters tab, right? And this is where we specify our fasta files that are going to be used within the run, right? To do that, you need to click on add, and you need to provide the fasta files that you have. You can provide more than one fasta file. You can provide fasta files from different sources. The ones that I have here are from Uniprot, and you can add it here. Now you might say, where do I get these fasta files? And the answer to that is, for example, you can get them from Uniprot, from this address here, right? So all you need to do is you need to go to a new tab on your computer, type in this address, and go to the website, right? And here you can see that they have archaea, bacteria, and eukaryota. So let's say I want to download the fasta file for human, and I know that humans are not bacteria or archaea, so I click on this, right? And there are many different options to choose from. Now let's say I don't know what human is, which of them is human. All I have to do is open a new tab and ask Uncle Google. I can say Uniprot human proteome. I can navigate there. I can go to the first result that comes up. I click on it, and I see that the proteome ID is starting with UP and ending with 5640. I can copy that, and I can hopefully go to this back here, and I can search in the page, and voila, it's here, 5640. That's the one for human. Now all I need to do is download this one here with the fasta in the name, and if I also want to, I can download this one, right? So I just need to click on that, click on this, wait a bit, it's downloaded, and I can navigate to the downloads folder. And again, all I have to do is to extract it. Now, these files are coming with the .gz extension, so you need maybe something like the software, special software to extract it. I use 7-zip, so you can just say 7-zip on Google and download and install it. I have done that before on my computer, and I already had the files, and so after you extract them, they look like this, right? They look like these two files, and we already uploaded them here, right? So that's all you need to do to set the fasta files. Now, there is a very, very important point here. If you use a certain fasta file for your library data processing of DDA files with MaxQuant, so you have made some measurements, DDA measurements, right? And you have processed them with MaxQuant using a certain set of fasta files. You have to use the same fasta files when you are analyzing. Otherwise, you get a nice error message complaining about the fasta files, and you will lose some computational time, and you will wait for some extra days. So be careful. Use the same fasta files for your DDA run and your DIA run. They should be the same. Okay. I hope that I could make that clear. And basically, after you have done this, after you have set everything else up here, you really don't need to do anything else. You can just go ahead and press start and wait for your results. Now, this was how you would run MaxQuant using MaxDIA for analyzing your DIA runs using libraries that you have measured. Now, let's say you want to use the discovery mode. So you have not measured any library, or you have, but you're also interested to know how you can, how different it is, and if the discovery mode is giving you better results. For that, what you need to do is you need to navigate to this address here. Okay. Let's open a new tab and navigate to annotations.perseus-framework.org. Yes. Now you can see that we have discovery libraries here. We click on that, and here we provide you, sorry, here we provide you with the same 3 files that I was talking to you about, the peptide, the msms, and evidence for several different organisms, right? For example, human here. So you click on that. I'm sorry. So very importantly, the FASTA files are here. So you have to use these FASTA files in your run. So you can download these FASTA files by just clicking on them. And then you can choose if you want to have 0 miscleavages or 1 miscleavage within your library, and then you can just click on that and download these files by clicking on it. Again, it's the same procedure. You go to the downloads folder and you extract these files, and then you can use this. The same for msms, the same for peptides. Here, back in the group specific parameters, in the type section, and just add them here. This is all you need to do to use the discovery mode. You have to come to our website, you download these files, and you put them here. And you make sure that in the global parameters section, you specify, you upload these FASTA files here. Okay, so I hope that's also clear. Now, another feature that is quite nice and new and novel is the fact that MaxDIA within MaxQuant now allows you to submit your results to the private repository with the complete submission. So the main difference between the complete submission and partial submission is that you use a standard file format. So in this case, Pride accepts mzTab and another format called mzIdent.ml. We provide the mzTab, and what happens is that they give you an identifier, and some journals actually require this, and it's also better for the community if you're sharing your results in that way. Now, all you have to do to be able to generate, the mzTab file needed for the complete submission is you have to, within the global parameters tab, navigate to the tables section and just enable this option here. And then MaxQuant will generate this mzTab file for you, which you can find again in the combined folder and under that in the text txt folder. So you would see this mztab.mztab file that you can use for your complete submission. Now, let's say you have, let's say you have completed a MaxQuant DIA run and you have your results, but you forgot to enable this option, and so you don't have your mzTab file and you can't do your complete submission. What you can do, and MaxQuant is very nice in this regard, is let's say I've done this run, it finished, I have my results, right? I've closed it, And then I remember I say, okay, I forgot to generate the mzTab file. What can I do, right? All you have to do is start MaxQuant, and every single DIA, every single project, every single project folder that you have processed with MaxQuant, in this case, this DIA data that we had, will generate such a file. It's called MQPAR. It's an XML document with all the parameters of your run in it. So if you have finished the run with MaxQuant and you have forgotten to generate the mzTab file, all you have to do is you go to File and you say Load Parameters. And you select this MQPAR file within your project folder. You can open that, and you see that our files are here, right? Our settings are all here. Everything is there, and you can just press partial processing. And now you can actually choose a step within the workflow where you want to start the run from again, so you don't have to spend a lot of time with time-consuming steps such as DIA preparation and such. So let's say I forgot to set that. I come to global parameters, I go to tables, and then I have selected this. I select that, right? And I go to partial processing, and I can just start the run from prepare writing tables. And in this way, MaxQuant will not do the entire analysis. It will use the results that are already in the folder and just write the tables from new, and you will get your mzTab file that you need to do the complete submission. Okay, so that was that. Now let's say you want to do a complete submission. How does that work? For that, you need to go to this website, right? We again open a new tab and we navigate to this website, right? Data submission, pride, and you need this PX submission tool, which you can basically very easily download by pressing this button. Again, after the download is done, you have to extract this zip folder, and you will end up with this folder, which I have done before, right? Navigate there, and for this, you will have to have Java installed on your computer. So you can, after you have installed Java, you can double click on this to run the software. But let's say your computer is new and you don't have Java installed on it. All you have to do is you have to navigate to this website here, and here you can download the Java you need. All you have to do is press on this button, and again, you will get an executable which will install Java for you. Very simple. It's here, right? So double click on it to get a dialog, and it's basically installed, next. Very simple, and you have Java installed on your computer. I've done that before as far as I remember. So let's see if I can run the submission tool. No, I haven't. See, but we can. You can install Java quickly. Just press install, wait a little bit, and Java will be installed. Okay, Java is installed. Okay, so we come here and we run the submission tool. So you need to register if you don't have an account already. I have one. I've registered before. So a complete submission is selected by default. Press next, and again next. And then you need to provide some sort of title for your project. So I will call it many titles. We need some keywords, MaxDIA, need some description. Since this description has to be more than 50 characters, I need to do this. Trying to just go to the next page to show you how it looks. Again, protocol, then you choose the type of experiment you have. So data independent acquisition is here, and you press next. And here is where you have to upload the files, right? So all you have to do is press add files, and you start with your mzTab file, which is in the combined folder under txt. You can just select it, right? And then it's automatically, the file type is set as result. You have other file types, but the software knows that it's a result file. Then you have to put in the raw files. So you have the raw files here, right? And then again, it knows that it's a raw file. Then you need to put the FASTA files that you had. Again, automatically it knows that it's the FASTA files. The next file is the MQPAR file I talked about, so that needs to go there. And then there is also one more specific set of files that MaxQuant generates for the complete submission. They are found under, again, the combined folder in MSP, right? You have these files here that you have to, again, upload. And again, it's the file type is correct. And one more thing that is needed is that you have to go to your folder where your data is. You need to zip this combined folder, right? By doing this, send compressed zip folder. And after that's zipped, you need to also upload, you need to also select that. Let's see if this zipping is going to happen fast. Okay, a little bit, take some time. But basically, after you have zipped your combined folder and you've also added it here, you are ready to do the complete submission. So you just follow the wizard and you have your project complete submission, and you can use it for your when you are publishing your study. You still need to the APL files for complete submission on top of mzTab, not for the case of DIA. For the case of DIA, you just need the MSP files and the mzTab.
Yeah, thanks for the nice introduction. I'm just wondering about whether these libraries, discovery libraries, will be available for other organisms.
To start, we have these 10, 11 species, but we have also instructions on how you can make them for other species on our website available, if I am right.
Okay, so that readme.txt has that info?
Yeah, so we have a link, but we have just for 10 species, as Hamid said, but not for all species. So, but totally correct. If you have, especially many people wrote Arabidopsis, unfortunately we didn't include it in the first trial. So we suggest for now to make it yourself, either using DeepMass, either Prosit, either Winner. So, but we will try to kind of really enrich our database of species. So not just 10 species, which we have right now, but more. But for now, as it is.
Yes,
yeah, my question is, do I select to match between run for DIA run?
No, match between runs, as explained by Pavel in the previous talk. You should not, that concept does not exist in DIA analysis, and that's basically be somehow being taken care of by the transfer Q value, right? Which, so you don't turn that on.